All right, let's move this down and extend. All right, so we're working on this lovely warm-up. Find the vertical asymptotes for this. Oh, and I can't move it at all. So I have to keep that up there. So I'm just going to work down here. So every single group started by doing the same thing, which is awesome. So what's our favorite F word?
Factor.
Factor. Okay. So x plus 2, x minus 2, we have an x, we have an x, we have a 2, we have a 1, we have a minus, we have a minus. Okay. So vertical asymptotes occur when you have a factor in the denominator that is not also a factor in the numerator. So if you look at the x minus 2's, because those are common factors, it's the same factor above and below, that would not be a vertical asymptote, that would be a whole. So when you have the same factor top and bottom, that generates a whole. If you have a factor on the bottom, so if you're dividing by 0, and there's nothing on top to essentially cancel it out, that's what generates a vertical asymptote. So for this problem, we would have a whole at x equals 2, and we'd have a vertical asymptote at x equals negative 2. So that's the actual answer. Not getting it right doesn't bother me a bit. Here's the thing that you got to watch out for. The thing you got to watch out for is this. If I say y equals this, and anywhere on my paper I say that this is in any way equivalent to x minus 1 over x plus 2, even if I still have the other factors there crossed out, then I would lose credit for the problem because they're not the same, right? I just lied. Anytime you lie, you lose credit. So, and the College Board uses that terminology a lot in their workshops. They'll say, whenever a student lies to us, we take off a point. So if I say this equals this, which they don't, I'm lying, right? So why don't these two equal? Yeah.
Because there's no asymptote anymore.
There's still an asymptote, but there's not a whole, right? Yeah. In other words, this one has a domain of all reals except negative 2 and 2, and this one has a domain of all reals except negative 2. Two different domains means two different functions, right? Okay, so be very careful that you don't accidentally say, hey, this equals this when it doesn't. You got to be careful with canceling. Now, here's the good news. In limit world, you can cancel your brains out because the limit of this is the same as the limit of this. Like if you have a graph with a hole, it doesn't matter if the hole is filled in or not. The limit's still the same, right? So as far as limits, if you had a limit here, x approaches negative 2, limit x approaches negative 2, or 2, like, or any number, right? That'd be fine, right? In limit world, it's the same. In limit world, you can cancel like crazy and all as well. It's only in function world that you can't cancel. All right, and I will tell you, you know, it's funny. So up until about it was either 2 or 3 years ago, the College Board wouldn't have given a hoot. They wouldn't have cared a bit. And then they changed the whole AP exam. I think it was 2 years ago. So 2 years ago, they rewrote and rechanged the whole thing, changed their emphasis, the format, the whole thing got completely redone. And one of the things that they published in slightly different words were, we are now officially going to be picky. So, but prior to then they weren't. Now they are picky. And they said, we will ding you every time you give us bad notation or you say something that's incorrect. We used to overlook. We're not going to overlook anymore. We're going to be picky. So you got to be real careful because the whole test is 108 points. That's one of the longest exams. It's a 4-hour exam, right? So you've got this 4-hour exam. The whole thing is 108 points. 1 point easily can be the difference between a 4 and a 5. So, and you'll take practice tests,
and you'll grade them and you'll be like, oh my gosh, I was 2 points away from a 5. If I hadn't written that one dumb thing where I canceled the terms top and bottom, I would have, so you think of all the dumb mistakes you make, like anytime you make an arithmetic mistake, or later on we'll learn about like not writing a plus C or writing a bad limit notation. All those little mistakes add up huge. So you got to be super careful. Yes?
For calc, like the AP test,
Mhm.
are like is the point system based on like how everyone else does, or is it like at the 80%, 60%?
Good question. It is based, it's a statistic, it is a normalized test. Like they wait until all tests are in, they get the statistics, and then they do their ranges from there. Yeah, so it is based on how other people do. So you're right. You don't have to outrun the bear. You just have to outrun the person behind you, right? So anyway, okay. All right. Okay, so today, 2-2b. Today we're going to focus on vertical asymptotes, or in other words, infinite limits. Limits that equal infinity. Today is the 5th or the 6th? 6th. Today's the 6th already. All right, September 6th. All right, the first 3 slides are fluff. You don't have to write anything down. So you can just kind of relax for a few minutes, and we're just going to talk about some stuff, right? So this first slide should be a review from yesterday. So they're just talking about in words, what does this mean? And you would read this as the limit of f of x as x approaches a is infinity. Now, technically, the limit of f of x as x approaches a, we write that it equals infinity, but really, what is the limit? Does not exist, right? This limit does not exist because the graph approaches infinity. But we write equals infinity as a courtesy to give a little more information to the person who's reading. And the College Board will expect you to do that as well. So this limit, very common practice to write the limit equals infinity as you approach positive infinity, or the limit equals negative infinity as you approach negative infinity. Notice for the positive infinity that it had to approach it from both sides. Both sides have to be pointing up to infinity for that limit to be positive infinity, or both pointing down for it to be negative infinity. If you got one of these guys, you can't write that the limit is infinity, and you can't write negative. You can't write plus or minus because you can't have 2 answers for a limit. There is either one answer or nothing. So if you got one of these guys, then it's a big DNE. No way around it. It's got to be the same from both sides. All right. So because of that, we're going to be doing a lot of left and right side checks today. So because we got to see if it's approaching infinity or negative infinity from both sides, otherwise we can't write the symbol. So for this guy, I'm going to start you off, and then I'm going to have you guys help me fill in the blanks. This, I'm going to tell you the first one though. So for this one, the graph approaches infinity from the left. For this one, the graph approaches infinity from the right. The graph approaches negative infinity from the left. And the graph approaches negative infinity from the right. Good. Now, is that okay? Okay. Little note, if I asked you for this first graph, like this is an A, if I said, hey, what's the limit as x approaches A of f of x, right? Say that was your question. What would you have to say for that graph? Does not exist. Because it's not the same from both sides. There isn't even a graph on the other side, right? There's got to be graph on both sides for the limit to exist. So that limit as a whole does not exist. From the left, it approaches infinity, but as a whole, it doesn't exist. Do you all understand that? All right. All right, last fluff slide, but this is a slide, even though it's fluff, I kind of like that it's here because it's time to talk for a few minutes about trig. So trig is
in all honesty, one of my favorite subjects in the world. I love trig. I wish I taught trig. I haven't been able to teach trig in easily at least 8 years. You don't get, when you teach calculus, you don't usually get to teach like calculus and pre-calculus, right? So you usually, if you've got calculus and still like a spot, you're getting like algebra 1. Like they're not going to say, oh, you get like all the highs and we're going to get like all of these. So because of that, I almost never get to do pre-calculus, which is a bummer because I love pre-calculus. But anyway, but that's okay. So I get to do I can't teach you all of trigonometry, but I can give you little like tips throughout the year, right? So we'll do like trig tips. So today we'll do some trig tips. So we're going to talk about vertical asymptotes of tangent. So you have your tangent, cotangent, secant, cosecant all have vertical asymptotes. And you got to be able to know where they are. Not so much because we're going to ask you where they are, but more it's going to come up a lot when we get into curve sketching. Again, not because you're going to have to sketch the graph, we call it curve sketching, but because you're going to have to analyze and make what I lovingly call sign lines. And this will help you know where your critical numbers are to put on your sign lines. So anyway, so you're going to have to know it. So how will we know where the vertical asymptotes are for tangent? Here's my little advice. Tangent is the same as what over what? Sine over cosine. All right, so that means vertical asymptotes occur whenever the denominator is 0 and the numerator isn't 0. So why? Because if both the denominator, like say in the last, like if we had an x plus 2 over an x plus 2, if we look at x as x approaches -2, if we plug it in top and bottom and get 0 for both, then we don't have a vertical asymptote. What do we got there? We have a hole, and that means that the limit's going to exist, and you're just going to cancel your common factors and plug in. So, and we'll get there tomorrow or Monday. We're going to do a whole bunch of algebra with a lot of factoring and canceling. It'll be a whole bunch of fun. But anyway, so when you get 0 over 0, not a vertical asymptote, it's a hole. 0 over 0 means there's a common factor. So what you're looking for is not 0 over 0. So anytime cosine is 0, sine is very much not 0. So we're looking for where cosine equals 0. All right, here's what you need to know as far as trig goes in this class. You should know, like in your soul, you should know sine, cosine, and tangent values for pi thirds, pi fourths, pi sixths, and your axes. Those are the 4 things, well, times all the functions, that I expect you to know. So if I go up to you and say, hey, what's the sine of pi 6? You should be able to just say it's 1/2, right? Okay, yeah, I know, I was pointing you, but I didn't want to put you on the spot, so I just asked the class. So sine of pi 6 is 1/2, right? And then, of course, if the sine of pi 6 is 1/2, what's the cosine of pi 6? Root 3 over 2, right? Okay, and then, you know, they swap for the pi thirds, right? And then pi fourths, they're the same. What are both of them at pi fourths? Root 2 over 2, right? So you just figured out sine and cosine for all those major angles, right? And then tangent, it's nice if you memorize. If you don't memorize and you just want to just think of it as sine over cosine mentally and write it down, that's okay, right? But anyway, and then of course all your co-functions are, you know, they're just reciprocals, right? All right, once you get those angles down, then it's a matter of just knowing if it's positive or negative, right? So when I'm asked like, hey, what's the sine of 7 pi 6? I haven't memorized the sine of 7 pi 6. I've memorized the sine of pi 6, and then I think which quadrant is 7 pi 6 in. And then I just answer with the appropriate sign. Now, there's a couple ways to do that. So I'm going to show you. So this is 0, pi halves, pi. Just so you know, have I mentioned it's always, everything in this class is always in radians. There's no degrees in this class. So in radians, so 0 pi halves, pi, 3 pi halves.
if I want to know 7 pi 6, well, pi, that would be 6 pi 6, right? So 7 pi 6 would be down here, third quadrant. So 5 pi 6 would be up here, second quadrant. Now, how do I know if sign is positive or negative? There's 2 ways to do it. One is to know the acronym, right? So one way is to know all students take calculus, right? How many of you have learned all students take calculus? Just a couple? Really? Did you all have the same teacher? Who was your teacher? Keki? So did Grukowski not teach all students take calculus? No? You just memorized everything? Yes, she did?
I think she did, but we just like.
Oh, okay. Okay. Did she do like all strippers take cash? No? Oh.
I remember that.
Okay. All right. Anyway. All right. All students take calculus. We once had a student named Curtis in our class, and the students all wanted to say, all students touch Curtis. So all students touch Curtis. So anyway, so you start in the first quadrant and you make a big C and you're in the fourth quadrant, right? What do these letters tell you? Your 3 primary functions, so your sine, cosine, tangent, they tell you which of those 3 is positive in that quadrant. So all of them are positive in the first. Sine is positive in the second, which means cosine and tangent are negative, right? Tangent's positive in the third, so sine and cosine are negative. Cosine's positive in the fourth, so sine and tangent are negative. Reciprocals keep the same sign as the original function. So in this quadrant, since how do I say this since I'm being recorded? Second quadrant, since sine is positive, cosecant is also positive, right? They keep the same, reciprocal functions follow the same sign as the original function. Just like in reality, like if I give you -2 and say, what's the reciprocal? It's -1/2, right? Okay. All right. So anyway, so that's one method. The other method is to remember what is your vertical and what is your horizontal component, your x and your y. So I personally think, Charles, how are you? Psi y coho. So psi y coho. Sine goes with your y. Cosine goes with your horizontal component, right? Okay, I know it's stupid, but that helps me. Psi y coho. Okay, so that just tells me sine is my y, cosine is my x in reality, but cosine horizontal, sine vertical. So if your sine is your y, right, well, y's are positive up, negative down. If your cosine is your x, x's are positive right, negative left. Okay, so that's another way to do your signs, right? Oh, everyone's coming in. Oh, senior meeting. I forgot about the senior meeting. Welcome, guys. You're missing a fascinating discussion on trig. Okay. All right. So does that like help at least just quadrants, that kind of stuff? All right, let's talk axes for a minute and then we'll get back to the lesson. Okay. So if you were to have a unit circle drawn, what's the radius of the unit circle? 1, hence the name unit circle, right? Okay, so if this is a circle with a radius of 1, then this point right here actually has the ordered pair 1, 0. So because it has the ordered pair 1, 0, your sine is 0 because it's your y, your cosine is 1 because it's your x. Now over the years, my brain has just memorized that all the whole number multiples of pi, right, all the integer multiples of pi, so 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, all of those have 0 for sine, right? And then for cosine, we're 1, we're -1. We're 1, we're -1, right, for all the multiples of pi. And then, so for all the whole number multiples of pi, my brain knows sine is 0. It's like when I look at this problem, I automatically, from 1 to 2, just 0. Let's look at this guy, right? So if you know your multiples of pi have a 0 sign, it'll help you, right? And then pi halves have a 0 cosine. And those would be 1 for sine, -1 for sine, 1 for sine, -1 for sine as you move around the circle.
And again, if you don't remember, if you can remember the ordered pairs, and just remember psi y, coho, sine 0, right? However you want to do it. There's a million ways to learn it, but anyway. So you just need to know. You need to know pi thirds, pi fourths, pi sixths, and your axes. Really, mostly for sine and cosine, but tangent comes up from time to time too. Okay. All right. So let's get back to the problem. We want to know where cosine is 0. So let me move this over down a little bit. All right, name just class. Name any angle that has a cosine of 0.
Pi halves.
Pi halves.
3 pi halves.
3 pi halves.
5 halves.
5 pi halves.
7 pi halves.
Whoops, that's a 2. Dot, 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 right? And we can keep going. Any this way? Negative pi halves, right? If we're going clockwise, right? We go backwards, we hit those negative angles. Dot, dot, dot. So you can go infinitely in either direction and have a cosine of 0, right? Okay. There's special notation for this, so you end up with those like pi halves plus k pi, where k is an integer kind of notation. Did you guys have to do that last year?
Yeah.
Okay, so some use k, some use n. I don't know what you guys use. Anyway, I'm not going to make you do that this year, and I didn't assign any problems that had that in the homework because I don't want to get bogged down in that notation, and it never, ever, ever, ever has been on the AP exam. So the only thing I really want you to know is how to find, like, as long as you can kind of list them out like that, because you will need to be able to find them when we've put them on number lines. But you won't, the whole plus k pi kind of stuff, that doesn't really come up at all this year. All right, so this would be what I'd be looking for vertical asymptotes of tangents, if I were to ask that question. That was a really long explanation for something that really isn't even on the homework. So are there any questions on this? But it might show up again. All right, good. It might be on homework. I don't remember if anything like this. It might be like maybe a multiple choice. All right, now we're finally in the lesson. All right, we are going to find the limit as x approaches 2 of x plus 1 over x minus 2. So let's call on some people. Keegan, how are you?
Pretty good.
Pretty good. Do you have any plans for the weekend?
I'll probably hang out with friends.
Oh, that's nice.
Yeah.
Nice, relaxing weekend.
Be fun.
Mm-hmm. It's supposed to be nice and cool outside.
Yeah.
Yeah.
Hopefully I can get some stuff done before winter starts.
I know. Yeah, winter is coming, right?
Yeah.
Okay. So Keegan, if you were to take that 2 and plug it in for x just on top, what do you get? And what if you plug it in on the bottom?
0.
0. So not 0 over 0 implies that what is going on there?
Oh, there's a hole.
Close.
Or asymptote.
There's a vertical asymptote there, right? 0 over 0 means there's a hole. Not 0 over 0, vertical asymptote. As a matter of fact, if you want to write down that somewhere in your notes, like 0 over 0 means hole. Not 0 over 0, vertical asymptote. When you have a hole, the limit exists. You just need to find it, and that's what we're going to do on Monday. Monday is where we start focusing in on all those holes. Today, we're just doing vertical asymptotes. So we're going to do all the not 0 over 0. Don't write this down because you'll get it wrong. Okay. So years ago, I would have written that, and I would have said, okay, so this limit, it's 3. You plug in, you get 3 over 0. So that means we've got a vertical asymptote. So then I would have said, okay, so then I would have checked my left, my right, and then come back with my answer and did something like that. Or negative infinity or DNE or whatever the answer was. Now, because I crossed it off, I would have been given full credit because the College Board will never ever grade crossed off work. They consider it the same as if it's erased. But if I ever left this up there, I would have lost my credit because the limit isn't 3 over 0.
the limit can't be 3 over 0. 3 over 0 doesn't even exist. It's not even a number. How can a limit be that? It's not a real number, right? So you can't write 3 over 0 even in your thought process of writing. You can't write something that's not true. So you used to be able to, but now the College Board is picky. So you can't. So here's what you have to do instead. This was their advice. They said, if you really need to see the 3 and the 0, which I like to, I'm a very visual person, draw a little arrow like that. And that way you'll say, okay, so the top is approaching 3, the bottom is approaching 0, not 0 over 0. So now I know I've got a vertical asymptote. All right, that makes sense? Okay, what do we do when we've got a vertical asymptote? So vertical asymptotes, your function can do this, 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 or this. And we got to know what it's doing to answer the question. The only way to do that is to check left and right. So we're going to start by checking the limit as x approaches 2 from the left. There is a long, convoluted, time-consuming, and cumbersome way to do this, or there's like a really fast 2-second cheating method for doing this. I like the really fast cheating method for doing this, and that's what I've stuck with for the last 15 years. It's pretty tried and true. It's never failed me yet. So that's what I teach. I don't know how other I do know how other teachers teach it. Most other teachers do not do the really fast, no work cheating method, but I'm not going away from it because it works great. So I'm going to teach you the cheating method, and that's what we're going to stick with. So here's the cheating method. So we're approaching, this is from the left, right? Because we have, and look at that, I said left, right? Okay, so this is from the left. So since we're approaching 2 from the left, we have to choose a number close to 2 from the left. Oh, I said right again. Oh, okay. So, Jennifer.
Yes.
Hi. Can you tell me a number close to 2 from the left? Okay, 1 is pretty close to 2, but it's too far away. A whole integer away isn't close enough, and the method can fail. So you got to go closer. 1.9 is fine. 1.99 is beautiful. 1.9 is fine. So I would pick something like 1.9. If you go about 0.1 away, you're guaranteed to be fine. All right, so you pick a number close to 2 from the left, like 1.9. You're going to plug it in, but you're not going to find the actual numbers. Who wants to do that? It's like you get all these decimals. All you're going to do is check the signs. That's it. All you need to know is if when you plug in a 1.9, do you get a positive or a negative? So, hang on, moving up the, Emma.
Yeah.
So if I plug 1.9 on top, do I get a positive or a negative?
You get a positive.
Get a positive, so I'm going to put a little plus sign. What about, Emma, if I plug a 1.9 on the bottom?
You get a negative.
You get a negative. Emma, what's a positive over a negative?
You get
A negative, right? This guy's going to negative infinity. No matter what, when you have a vertical asymptote, left or right, it's going to an infinity. You just need to know which one. So the sign is going to tell you, is it positive or is it negative? And Tyler, what's your question? Very good question. So now we got to do from the right. Right here you have to go from the left. So now we're going to go from the right. So now we're going to choose, so from the right, we're going to choose 2.1. All right, so Faith. Hi, Faith. How are you?
Good.
Good. Faith, if I plug a 2.1 in on top, what do I get? You get a positive. What about on the bottom? Also positive. What's a positive over a positive? A positive. So this guy's going to positive infinity. Remember, you don't have to know the numeric value. You just have to know the signs. All right, so Zuhair. If the limit from the left is negative infinity and the limit from the right is positive infinity, what's the limit as x approaches 2?
Because it's not the same for both sides. Right? Tweet Ian? Is that right? Yes. Good. Okay. Do you kind of get the strategy? Because you're about to do it a bunch. Question. Wait. Okay. Ishan?
Yeah.
Did I say it right? Okay.
Wouldn't this like not work if like it splits like really far down in the negative and really high?
So here's the thing about that. So for it to cross the x-axis, so his question is totally valid, right? So for this problem, let's just take a quick peek at what this looks like. So we have, let's see how good your algebra is. There's a horizontal asymptote for this function. Where's it at?
Oh,
it's a negative 1.
That's y equals 1. Because the degree top and bottom is the same, and it's the quotient of the leading coefficients. So we have a horizontal asymptote at y equals 1.
I remember that.
Yeah, I remember this.
Yeah, so if it's
It's been a while, right? That's okay, right? Gotta get the cobwebs off. That's okay. So we have a vertical asymptote at 2. All right, so what we have is we have this thing that's going to negative infinity on the left, and it's going to positive infinity on the right. So Ishan's question, totally valid. So where the problem is when you're plugging in, you got to make sure that you're plugging in a number that's close enough so that it doesn't actually cross the x-axis past that number, right? What if it's like a really, really steep function and it doesn't cross the x-axis until like 1.99999? Now, intuitively, you'll know it because if it did, you'd get a different sign. This one, the only thing on the bottom is 2. So you're really just, am I left of 2 or am I right of 2? That's going to determine the sign. So the difference between 1.9 and 1.99999 actually is irrelevant. It doesn't make any difference at all because they're all going to be, it's going to be the same sign no matter what, right? So you just have to be careful. This one, it's super easy because it's all just integers. And never in the history of the world has the AP exam ever given a problem where like it was different by 0.0001 where you had to know, right? So it's always worked. Just go a tenth away and it'll always work. But that is something to be careful about if we're dealing with like real world, not college board stuff. It could technically be positive and still approach negative infinity if it came to that vertical asymptote at a point like really, really close to it, right? But you would normally see that though you'd be able to visually see it in your function if that happened. Good question. All right. Good. Let's move on. Are there any questions on this? Because I'm going to make you guys try it now. Here we go. All right. There are 6 problems on the board. But they're really they're just 3 or 2. There's really just 2 with 3 parts each. So you have 2 functions, and for each of the functions, I make you do a left, a right, and then find the limit. What I want you to do is sit silently and work for about 30 seconds, and then after 30 seconds, I'm going to say, all right, you can talk, and then I want you to compare answers with your group and see what you've got so far. All right? So go ahead and begin. Okay, talk to each other. You're running a recording.
With Nitty. Nitty, for the first one, left of 5, what number did you pick? 4.9. And when you plug it into the top, do you get positive or negative? Negative, because you're subtracting 1,000, right? What about on the bottom? Positive. Hey, what do we know about the bottom? It's always positive. Why? Because it's being squared, right? Positive or 0, but in this case, it'll always be positive. So Nitty, what's negative over positive? Negative. So this guy's negative infinity. All right. All right, Ishan. What number did you pick for 5 from the right?
5.1.
Okay, when you plug 5.1 in on the top, what do you get?
Negative.
You get a negative. That's hard to, sorry, it's getting messy. Okay, on the bottom you get a positive, so this guy's going to
Negative.
negative infinity, which means, Mahika, what's the overall limit? Negative infinity. If they match, that's your limit. Oh no! Think I can make it for like the next?
I don't think so.
That's usually the 5.
Does anyone have a charger with them?
Especially with the.
Not a single person in this class has a charger?
I think I got it.
Otherwise, I gotta run all the way to the office.
I
No?
had it.
Do you have a computer charger with you? Look at you, and it's all like wrapped up in neat. Wow, thank you. It's even got like the cord stuck into the little thingy. Okay, there we go. All right. Who just gave that to me? Lucas? Did you give me the cord? Thank you. Okay. See how fast I forget things? That was fast. Okay. All right. Okay. All right. Lucas saves the day. That's the name of today's lesson. All right. So now we're moving from Lucas to Luke. Hi, Luke. Okay. We need a number that is to the left of -2. What number did you pick? -2.1. Do you guys understand? Like, think number line, right? There's -2. We want to be to the left of it, right? You're going -2.1. Okay? -1.9 is greater. So, -2.1. So, if you plug in, Luke, if you plug in a -2.1 on top, do you get positive or negative? Positive. Good. What about on the bottom? Positive, right? Square anything whose absolute value is bigger than 2, and you're going to get a number bigger than 4. All right, so positive over positive, so this guy's going to positive infinity. Beautiful. Good job. All right. Vishali's not here, okay? Tarun. Hi, Tarun. All right. What number did you pick from the left? -1.9. Plug it in on top. What do you get?
Positive.
Positive. What about on the bottom?
Negative.
Negative. So this guy's going to negative infinity. And Kirthana, that means that our limit does not exist. Beautiful. Any questions on these? All right. So, last problem of the day. I want this on paper, not whiteboards, on paper. I want you to see if you can draw a function that fits all 7 of these requirements. You did this a little bit yesterday. Now we're going to do it like for real, like a good big one, right? A few hints. I personally always start by plotting the dots. If this was like on a test and I was grading it, it would probably be a point a thing. So I would just sit there and like check off. They got that, they got that, they got that, they got that. So the first thing I'm going to look for are the dots because those are the easiest things to check, right? So your function values, plot the dots, then start working on your limits. Little word of advice, the bottom 2 here, you haven't learned how to do yet. You will be learning them in a few days, but I just want to see if you can figure these out. It's just kind of a, let's see what you can do. Feel free to talk to each other the whole time. This could be a group activity if you want to work together, if you want to work alone a little bit and then talk to your group about a few that are bothering you, that's fine. But I want there to be a little bit of, discussion going on while you're working. All right. First thing that we're going to do is make sure we plot the dots. So -2, 3, and 1, -2. The limit as x approaches -2 has to be -1. We already have a point at -2, so I can't put another point here. What am I going to have to put? An open circle. There's got to be a hole there because you can't have 2 points vertically or it's not a function, right? Got to be a function. All right, so you have to have a hole there. For that limit to exist, it's got to have graph coming in and graph coming out. We don't know where the graph's going to go yet, but it's got to have graph on both sides or that limit isn't -1. All right, limit as x approaches -4 is negative infinity. What's going on at -4? Vertical asymptote, right? Faith, right?
Yes.
Yes, very good. So we draw, I'm just going to sketch a little vertical asymptote dotted line, and I'm going to make that guy point down to negative infinity. Does that accommodate that? Got to be from both sides. So I got to have the other side also pointing to negative infinity. All right, so now I've got my limit as x approaches -4. I've got my next dot. So I've already checked off kabam, bam, bam, bam. All right. X approaches 1 from the right has to be 2. I already have a dot at 1. So what do I have to put here? Open circle. And then from the right, nothing has to connect here from the left. Literally, this would be correct. Now, this would drive me insane. It would be correct, full credit for what we've done so far, but doesn't that make your shoulders go up? Doesn't that go, ugh, right?
Yeah.
Okay. If it doesn't, that's fine. Just leave it, right? Does it matter if I connect this guy to the circle or to the dot? No, it makes no difference, right? They'd both be totally correct. This would be correct, right? So I probably connect to the circle, but if you connect to the dot, that's fine. They're both correct. All right. You can't do both, though, right? Because then it's not a function. Okay. All right. Now we get to the stuff that we haven't learned yet. The limit as x approaches negative infinity and x approaches infinity. Those are end behavior descriptions. X approaching negative infinity is way out here, and x approaching infinity is way out here. So really, this is kind of saying, hey guys, as x approaches negative infinity, we basically have what's called a horizontal asymptote at 3. So you want your graph somehow to kind of flatten out at 3 as x approaches negative infinity. So in the left direction and behavior, we would flatten out at 3. Our right end behavior way out here, we just need to always be going up, right? The right side is always pointing up to infinity, so anything that's always pointing up is fine. Horizontal asymptotes and vertical asymptotes are not electric fences. You can cross them. They have nothing to do with whether you can cross or not cross. They are literally just a description of end behavior. What is your graph doing at the far left end? What is your graph doing at the far right end? So I can have a graph, right? Say I have a graph that goes like this. So flattens out here at -2, and then up here goes like that at +2. This would have a horizontal asymptote of +2 and a horizontal asymptote of -2. The right end behavior means that as you approach infinity, your y value is approaching 2. The left behavior, as you approach negative infinity, the y value is approaching -2. 2 horizontal asymptotes, one for each end, right? Or you could have this be a horizontal asymptote, and then that guy could just point down and not have a horizontal. You just have one horizontal asymptote, right? Or you can have no horizontal asymptotes if they just, don't flatten, right?
So anyway, but it has nothing to do with like not being allowed to cross a line. It has nothing to do with drawing dotted lines anywhere. The dotted lines are just for your guidance when you're graphing, right? So really, it's just what's happening at the ends. That's what a horizontal asymptote is. Okay, so which we'll get into more next week. And here endeth the lesson. So